Good morning, everyone. My name is Christian Martinez. I am a computer engineer, and I am in charge of software.
And my name is Mohamed Bilal. I was in charge of hardware.
My name is Ryota Watanabe. I'm computer engineering, and I'm in charge of software.
Our fourth member, Heber Salazar, is an electrical engineer and is in charge of testing. He couldn't be here today because he had an important job interview, so good luck to him. We are Team 678, and we worked on the multifunction outdoor module, or MOM for short. So we set out to work on a project that captured all our interest in order to keep us motivated. So we chose to work on a renewable energy project that will be using various renewable energy technologies, and in order to power multiple essential electronics that you can use outdoors, both for safety and in entertainment purposes. The three renewable energy technologies that we used were kinetic, solar, and thermal. For kinetic, we used a dynamo generator that which converts kinetic energy into electrical energy in means of using a rotational crankshaft. For solar, we attached two solar panels to the left side and the right side of the exterior side of the unit. On the left side, we had a rectangular solar panel, which can be folded up by hinges in order to get a 90-degree angle out away from the box in order for it to face the sun a lot better. On the right side of the unit, we attached a more compact solar panel, which is a 3-part foldable solar panel, and that is attached by Velcro. In doing so, we can unjoin the Velcro from the solar panel and move it away from the box up to 11 inches away, where you can then separate that foldable solar panel. So say you're in the shadow or in the shade and you want to increase the amount of sunlight you get on a solar panel, you can extend it away from the box and put that in the sunlight. For thermal, we employed 10 tile-like 40 millimeter by 40 millimeter thermoelectric generators, which basically take advantage of a temperature gradient. In doing that, they generate electricity, and basically you keep one side of the tile at a large amount of temperature while you keep the bottom of the tile at a cooler temperature. So we connected 10 of those in series and sandwiched those in between two copper sheets, where the top of the sandwich is exposed at the top of the unit, which will be heated by a Fresnel lens that you see on the top, which looks circular. And that Fresnel lens is being it's a movable Fresnel lens by an indicator base, which acts as an arm. And this elbow joint can be tightened and untightened in order for you to move it freely wherever you want. So the bottom of that sandwich of the copper sheet is enclosed inside the box, and that bottom side of that copper sheet is kept at a cooler temperature by two heat sinks, ones that you usually see in a mini desktop PC, and cooled by two heatsink fans along with it. So, to wiring all these together, we were able to charge a lithium-ion battery pack. And this device mainly powers a touchscreen display, two USB ports, and a Raspberry Pi, which acts as the central controlling unit to power on and off a speaker, the radio components, two heatsink fans, and two lights. One of the lights being a focus light where you can direct it into a certain area in the dark, and one being a floodlight, which will illuminate a general section of the dark. In conclusion, we used our device to power essential electronics that you would use outdoors, mainly for campers, tailgaters, people that would like to be in a fixed area, like fishermen. And we really enjoyed working on this project. How much time do we have?
Okay.
Okay. So we really liked working on this project, and we'd like for you guys to look at our poster session, and we can talk more about it in detail. We can open up for questions right now.
Any questions?
Are you contemplating using piezoelectric devices also to enhance the conversion of kinetic energy or vibrational energy into electricity?
Given that the box will not be moving a lot, so I think that it's going to generate a lot of electricity for us in this case.
Okay.
So,
Thank you.
Is this meant to be kind of used as this generating electricity you're using it immediately? You know, so it's not designed to store the energy, right? Because I see the weight is 30 pounds, but it can only hold 74.4 watt hours of capacity, whereas you can buy battery packs that can hold much more than that for much lighter weight.
So the weight is actually because of the box, because we were looking at different materials, given the time and resources. It's actually the weight of the box that is a lot. So that's, yeah, we could put in a bigger battery, but for now it's 75 hours.
Right. Any more questions? If not, we can thank the team.